Okay, class, in this lesson, I'm going to show you how to write and solve inequalities and graph them on a number line. So before we get started, we need to understand what an inequality is. So an inequality is a mathematical sentence that compares quantities that are not equal. And the symbols that are used to represent an inequality can look like this, or this, or this, or this. And each one represents the following. So the first one is called less than. To read the sign, you go from left to right, and you can see that the point is on the left side and the open portion of it is on the right side. When you see that, it means that the quantity to the left over here is less than the quantity to the right. Likewise, the next symbol represents more than, and that is the quantity on the left side is more than the quantity on the right side. The third symbol looks like the first one, except there's a line underneath. And what this means is any quantity on the left side of this inequality is less than or equal to the quantity on the right side. And finally, the last one represents a quantity on the left side that is more than or equal to the quantity on the right side. Okay, so let's go over a couple of examples so you understand how to solve for inequality. So let's suppose we have this following statement. 2x minus 1 is greater than 4. To solve for this inequality, the steps that you use is the same as an equation with an equal sign. Okay, so in other words, you're going to move the -1 over to the right side. To do that, we need to add 1 to both sides. So then what we get is 2x, and we keep the sign the same, is greater than or equal to 4 plus 1. Then we combine the 4 plus 1, and we get 2x is greater than 5. Now we want to move the 2 over to the to the right side. Okay, since this is a product, the way to move the 2 over to the other side is to divide both sides by 2. And when you do that, you get x is greater than 5/2. So what this means is that for any value x, as long as it is greater than 5/2, that value will make this expression valid. If x is exactly 5/2, it will nullify or not make this expression or statement correct. Because when you plug in 5/2 for x, we get 5 minus 1 greater than 4. 5 minus 1 is 4, and 4 is not greater than 4. And that's what makes it invalid. But if you take a value less than 5/2, for example, 0, and you plug that in for x, this term disappears, and now we have -1 is greater than 4. So as you can see, 0 is not greater than 4. So you can't plug in a value that is less than 5/2. But if you pick a value greater than 5/2, for example, 3, if we put 3 in for the value of x, the product of 2 and 3 is 6, minus 1 is 5, and 5 is greater than 4. So that is correct. So essentially, anything that is greater than 5/2 will make this expression valid. Okay, so let's take a look at another example. Okay, so we have negative 2a plus 5 is less than or equal to 21. So to solve for a, the steps that we take will be similar to a statement where there's an equal sign. Okay, so what we're going to do first is we're going to move this 5 over to the other side. And to do that, we need to subtract 5 from both sides. And when we do, we get negative 2a is less than or equal to 21 minus 5. Then we're going to subtract 5 from 21, and we get negative 2a is less than or equal to 16. Okay, so now we're going to need to remove this negative 2. Okay, and to do that, we need to divide both sides by negative 2. So what we're left with is a, and I'm going to leave this inequality blank for a second, and we're going to finish the computation. So 16 divided by negative 2 is negative 8. Okay, so the reason I left this inequality for last is because I wanted to tell you that when you multiply or divide by a negative number, the inequality needs to flip around. In other words, this now becomes greater than or equal to negative 8. Okay, so the only time you flip or switch the inequality sign from less than to greater or greater than to less than is when you are multiplying or dividing by a negative. If you're adding or subtracting a negative number, there's no switching around. Only when you multiply or divide by a negative number. Okay, so let's test this out. This basically says that for any value of a, as long as it is greater than or equal to negative 8, it will make this statement true. So let's try negative 8 and see if it is true. Okay, so we have negative 2 times negative 8 plus 5 less than or equal to 21. Is that true? If we multiply this out, we can get 16 plus 5 less than or equal to 21. 16 plus 5 is 21, and therefore 21 is less than or equal to 21. Okay? So that checks out. What if we picked a number that is not greater than or equal to negative 8? So let's say negative 10. Okay, so if we plug in negative 10 into the equation, we get negative 2 times negative negative 10 plus 5 less than or equal to 21. Let's see. So when we multiply this out, we get 20 plus 5. Is that less than or equal to 21? You add the two terms together and we get 25 less than or equal to 21. No, this does not work. So whenever you solve for an inequality, it's always important just to test it to make sure that your answer is correct. Okay, so now I've shown you how to solve for an inequality. Now I'm going to show you how to graph an inequality on the number line. So in the first example, we solved for x and we got x is greater than 5/2. To graph this, we're going to draw a number line. Okay, and we're going to label this 5/2. Okay. So we want to graph this number line to represent for all values of x greater than 5/2. When you have a greater or less than sign, you want to put an open circle on 5/2, and then you're going to draw an arrow to the right. So this green circle with an arrow to the right means that for all values greater than 5/2 will make the statement true, or make the previous statement true. And likewise, in the previous statement, we solved the inequality and found that a is greater than or equal to -8. Okay, so to draw this on the number line, we're going to mark -8. Okay, now the difference here is we have a greater than or equal to. Because this is equal, we're now going to put a closed circle at -8, and then everything to the right would mean greater than -8. So the circle, the closed circle, means equal to, and then the arrow to the right means greater than. So therefore it represents greater than or equal to. Now let's suppose we had something that said y is less than 2. So to graph this on the number line, we're going to mark a 2 here. And because this is a less than sign only, we're going to have an open circle at 2 and draw an arrow to the left representing all values less than 2. Okay, so hopefully this was pretty straightforward. If any of this was confusing, please go back to the beginning of the recording and review this again. Thank you.